This is our AP Calculus quiz given on November 11th, 2015. This is a 5-part problem based on a function, a position function from which we find out things about the speed and acceleration and velocity of the particle and so forth. A particle's position along the x-axis for t is greater than or equal to 0 is given by the function x of t equals 1/3 t cubed minus 3/2 t squared plus 2t plus 3. The position is in meter and t, or time, is in seconds. And so for this, it says part A, what is the particle's position and velocity at t equals 4 seconds? So what we're going to do is substitute in 4 in the original function. So we're going to say x of t, we're going to say x of 4 is equal to, we're going to have 1/3 times 4 cubed minus 3/2, we have 4 squared plus 2 times 4 plus 3. So it becomes at this point a matter of simplification. So x of 4, which is our position at t equals 4, is 4 cubed, which is 64 over 3, and then minus 3/2, 4 squared, so that's going to be 4 squared is 16, and 3 times 16 is 48. So we have, I'll just write down 48 halves. And then we have 2 times 4 plus 3, well that's going to be 8 plus 3, so plus 11. And these are going to be, let's see, x of 4 is going to be equal to 64 thirds. And we have 48 over 2 is going to be minus 24 plus 11. So that's going to be equal to x of 4 equals to 64 over 3. And negative 24 plus 11, that's going to be minus 13. And that's going to be 64 thirds minus, we're going to have, let's see, 13 and thirds is going to be 39 thirds. So we're going to have 25 thirds. And so it's going to say, we're going to write this as x of 4, position at time equals 4, equals 25 thirds, and we have meters, right? So we'll say meters. So that's going to be one of our answers. That's going to be our position answer. Next we go to velocity. Our velocity is found by taking the first derivative. So velocity, v of t, is equal to x prime of t. And for that we have the equation, we have t to the third, so we take 3 times 1/3, we're going to get t squared. And then we have, let's see, t squared, well 2 times 2 is going to cancel each other, so we have minus 3t, and then we're going to have plus 2. And to find our velocity, we're going to say v of, which is x prime, v of 4 is going to be equal to 4 squared minus 3 times 4 plus 2, which equals 16 minus 12 plus 2. So v of 4 is going to be equal to, that's going to be 6, right? Because we have 16 minus 12, that's going to be 4 plus 2 is 6. So we have 6, and that's going to be in meters per second. So that'll be our velocity at t equals 4 seconds. Next part of the quiz, we have B, when is the particle at rest? Well, for that, we take our v of t, and that's going to be t squared minus 3t, and that's going to be plus 2. And so to find when the particle is at rest, we set the velocity equal to 0. So we put 0 equals t squared minus 3t plus 2. And now we'll attempt to factor. 0 equals quantity t minus 2 times quantity t minus 1. So we have t minus 2 is equal to 0, and t minus 1 is equal to 0. So we have t equals 2, and we have t equals 1. So when is the particle at rest? At, let's put an at sign, t equals 1, and t equals 2. Now the justification is why? Because at these locations, v of t, which equals x prime of t, is equal to 0. So that would be our answer. So something like that for a answer and a justification. Next part, C. Okay, we already have when the particle's at rest. D. What is the total distance traveled by the particle in the first 2 seconds? I think for C I meant to put the same thing. I need to put when is the particle moving to the left, but that's all right. Okay, during the first 2 seconds, let's go ahead and look at this. If we just look at our critical points, 1, 2, if we put velocity in the top and we put x of t in the bottom, when we have our function, which is going to be, remember we had 0 equals quantity x minus 2 times quantity x minus 1. Okay, for less than 1, we're going to have a negative times a negative. So our velocity is going to be negative. And so the function value will be decreasing between 0 and 1. And when we get between 1 and 2, say 1.5, we're going to have negative times a positive. Okay, I got that mixed up. Positive to the left, negative times negative. Positive to the left of 1 between 0 and 1. And then we put in 1.5, we're going to get a negative times a positive. So the function value is decreasing between 1 and 2. And then to the right of 2, we are increasing again. So what is the total distance traveled by the particle in the first 2 seconds? Well, basically, we're at 0, and at 1 and 2 are the points that we are interested in. And that's going to be at 0. Well, at 0, we already, if we go look at our original equation, we're going to have 3. Right, so 3. So 3. And if we plug in 1, we're going to have our position x of 1 is going to be equal to 1/3 times 1 cubed minus 3/2 1 squared plus 2 times 1 plus 3. And for that, we're going to have 1/3 of 1 cubed, which is going to be 1/3. And then we're going to have minus 3 halves of 1 squared. That's just going to be minus 3 halves. And we're going to have plus 2 plus 3, so plus 5. So for that, 1 minus, we can write this as in sixths, is we're going to have 2 sixths, that's what 1/3 is, minus 9 sixths, that's what minus 3 halves is, plus 30 sixths, that's what 5 is. So we're going to have 2 minus 9, which is negative 7, plus 30. Negative 7 plus 30 is 23 sixths. And 3 over 6. And 3 is going to be in sixths, 18 sixths. Okay, next we're going to go to 2 seconds. X of 2 is equal to 1/3 times 2 cubed minus 3 halves times 2 squared plus 2 times 2 plus 3. And for that, we're going to have 2 cubed is 8, so we're going to get 8/3. And we're going to have minus, well, 4 squared is going to be, 2 squared is 4 times 3 is going to be negative 12 over 2. And then we're going to have plus 2 times 2, which is 4, plus 3 is going to be plus 7. So we're going to rewrite this all in sixths. Okay, 8 over 3 is going to be 16 sixths. And we're going to have minus this 12. Well, 12 over 2 is going to be the same as minus 36 over 6. And then we're going to have plus 7, which is going to be plus 42 over 6. Plus 42 over 6. And that's going to be 16 minus 36 will be negative 20. And negative 20 plus 42 is going to be 22 sixths. So we're going to have 22 sixths right here at t equals 2. So between 18 sixths and 23 sixths, we're going to go to the right 5 sixths. And between 23 sixths and 22 sixths, we're going to go another, but to the left, 1 sixth. And 5 sixths plus 1 sixth equals 6 sixths, which is going to be 1 meter. So that'll be our distance covered. Now backtracking a little bit, I have this wrong in my file here. It should say for C, when is the particle moving to the left? Well, that's going to be, again, our critical numbers, 1 and 2, and we have v of t up here, and we have x of t down below, and we have, to the left of 1, we have positive moving to the right, negative moving to the left, and then positive moving to the right. And so when is a particle moving left? That's going to be particle moves left on the interval from 1 to 2. And why is that? Because v of t is less than 0. So that's PART for particle. There we go. That's our answer to part C. Answer to part E. At t equals 4, is the particle speeding up or slowing down? Justify. Before that, we need to find the acceleration. Remember, we had our v of t equals t squared minus 3t plus 2. So a of t, which is our acceleration, equals v prime of t, which equals x double prime of t. So we're taking the second derivative, essentially. So we're going to get 2t minus 3. And now if we set this to 0, we will see where this is. So if we say set the acceleration to 0 equals 2t minus 3, we get 2t is equal to 3. So t equals 3 over 2, or 1/2. So coming back to our number line, which we're going to do right up, I'll go in this original function. No, I'll just make a new one. Okay, remember we had our critical numbers of 1 and 2, and that's going to be v of t up here and x of t here. And so we have positive to the left of 1, our velocity, negative between 1 and 2, and positive greater than 2. And this next one I'm going to make is one for acceleration, which is going to be a of t over x of t. So velocity, we're going up, position going up, down, and up after 2, okay? Now, our critical number for acceleration is going to be this between 1 and 2 of 3 over 2. And to the left, if we look at this function 2t minus 3, if we have to the left of 3 over 2, we say plus 1. 2 times 1 minus 1 is negative. So we are concave down between 0 and 3/2, and greater than 3/2, like 2. 2 times 2 minus 3 is going to be positive. So we have concave up between 3/2 to infinity. And so at 4, we're going to have the particle is what? At t equals 4, particle is speeding up. Because v of t and a of t are both positive. And more correctly, we would say have the same sign, positive, or have the same sign. If they were both negative, we would still be speeding up, but if one was negative and one was positive, velocity positive and acceleration negative, or velocity negative and acceleration positive, we would be slowing down. So that concludes the test, the quiz we had. Hope it worked out well for you.